This lesson is for FST, lesson 4.9, called the Graph Standardization Theorem. The Graph Standardization Theorem used to be called the Rubberband Theorem, which I find to be a more useful title. Most students, I'm sure, have either tried this themselves or seen it done, and that is shooting a rubber band with your fingers. When you shoot a rubber band or something in a rubber band with your fingers, you would usually stretch the rubber band, and then when you let go, the rubber band translates to a new location. So the Rubberband Theorem is a really nice title for the Graph Standardization Theorem because it helps you remember what order to go in. You should stretch and then translate. Just like when you shoot a rubber band, you stretch it out, and then when you let go, it translates or slides to a new location. So when you're working with items in Lesson 4.9, there will be two pieces to the rule. The rule will have a translation and a scale change. Notice the composition symbol in the middle here, the open dot. Remember that the open dot means follows, so the translation is going to follow the scale change. So students always need to go in that order. Scale change first, translation second. Many times you'll see the two rules put together as it is listed here. And so it's important for students to kind of list out the four things so that they don't get confused on which piece goes with what. Remember that the rule and the equation are going to be opposites of each other when the values are with the y. When they're not with the y, it's going to be opposite of the rule for the x's, but the same as the numbers for the rule with the y. So always opposite for x, and then it depends on the y if you're going to be the same or opposite. If the y is alone, the values for the y are going to match in the equation that they do in the rule. If the numbers are with the y on the same side of the equation where the y is located, then you will do the opposite of the rule to the equation. It's also important that students remember and keep in mind that if the coefficient of x is not a 1, you need to factor out that coefficient by dividing. And I'm going to illustrate what that looks like with some examples today. So let's go ahead and give this a try. We're going to focus mostly on the equation part of it, and then we'll finish up with a graphing question. Give the amplitude, period, phase shift, and vertical shift for the given equation. 4 cosine x minus pi over 5 plus 3. So I'd recommend writing the scale change rule and the translation rule. So let's start with scale change. Remember that the scale change, well actually we can write them both kind of at the same time. So remember the scale change is what you're multiplying by. So if you look at what the x is being multiplied by, well, it's not really being multiplied, it's actually being divided by a 5. So if in the equation you're dividing by 5, in the rule you're going to be multiplying by 5. For the y value is alone, so the number that would normally be with that is over here, that's the 4. So we would say times 4y. If it was over there, it would have been in division form and we would have done the opposite. For the translation, we want to look at what we're adding and subtracting. The x is currently being subtracted by a pi. So in the rule, we want to be adding a pi. Notice that we don't need to worry about the 5 because that was what we were dealing with back here with the scale change. So the scale change has already removed the 5 out of our situation. If you were doing the order of operations here, wouldn't you do x minus pi and get an answer for that and then divide by 5? That's because you've done the translation already. So it's not pi over 5, it's x minus pi over 5. That's why this bar is super long. So the 5 is separate from the pi itself. So we were minusing pi subtracting pi from x in the equation, so in the rule we will be adding pi. For the y value, again the y is alone, so whatever extra is happening that's not with the x stays the way that it is. We're going to say y plus 3 here. So now let's go ahead and list out some information about what's happening here now that we know the rules. The amplitude here, remember, is the b value. The b value is the number next to the y, so that's a 4. So if you think about what this graph is going to look like, it's going to get up to 4 and down to negative 4. The period, remember, is the result of doing 2 pi times a. The a here is the 5, so 2 pi times 5 is going to be 10 pi. So it's going to take this graph 5 times as long as normal to complete its full cycle. Phase shift is next, and remember the phase shift is the same as the horizontal shift. It's being added to pi right now, so that means it's moving to the right by a value of pi or 180. So the phase shift I'm going to put here is a positive 180, positive pi or positive 180. Could also remark here that it is to the right. And then the vertical shift is the last thing we need to mention. The vertical shift is going to go up 3. So far so good on the graph standardization theorem. Let's try a few more here. Rewrite and identify the transformation rules, amplitude, period, phase shift, and vertical shift for the given equation. This is one of the ones where I want to show you what happens when the coefficient on the x is not a 1. So hopefully you guys noticed that right here. This 3 should be or needs to be a 1. So we're going to have to do a little bit of math before we can start listing out our scale change and our translation rule. So to get rid of that 3, I would need to divide by 3, because then that would make that a 1. So if I do that, because I'm inside parentheses here, I would need to do that to both pieces. So if I divide by 3, that's actually going to move my 3 out here. And actually what I want to do here is not divide, I apologize. I want to be factoring out the 3. So I'm going to pull the 3 to the outside of the parentheses. So my new equation is going to look like this. If I pull the 3 to the outside, leaving that x alone, I want to figure out what I would need so that when I do distribute the 3 back in, I get this statement back. So I need to come up with 3 times what is going to give me negative pi back. So what I need to do is basically, to figure out what I'm going to get, I basically divide both of these by 3. Even though I pulled the 3 out to the front of the parentheses, to get my result for what's left, I would divide each piece by 3. So earlier I had just divided too early. So if I pull the 3 out, divide both of these by 3, I'll get my answer. So 3x divided by 3 makes just an x, and negative pi divided by 3 is now what I need since I pulled this 3 outside of the parentheses. If you're not sure if you trust me on this, just do distributive property on what we just got. 3 times x is 3x. 3 times negative pi over 3 is negative 3 pi over 3. 3 over 3 cancels, leaving you negative pi, which is what we had to begin with. So all we're doing is factoring out the number. When we do that, we're dividing both pieces by 3 to see what's left. So that's how you factor out to get a coefficient of 1. And then I've got my minus 2 there. So now I've got it set up in a way where I can find all the pieces for my rules. So let's do scale change and translation rules here. Now I am being super brief here. We should technically be doing x, y, and then we should do the equal sign and all of that. But if you run out of time and just say s equals and t equals, I'll probably be okay with that. So for the scale changes, remember we're looking for those multiplication pieces. Right now in the equation, we are multiplying by 3. So in the rule, we would be dividing by 3 or multiplying by its reciprocal, which is a third. So here we're doing times, so in the rule we're doing divide. Similarly for the 6 should be on the side where the y is. Since it's not, it's going to be multiplication in the rule. For the translation, the x is subtracting pi over 3, so now it's going to be adding pi over 3. The other piece should be on the side where the y is. It isn't, so it stays the way that it is. Now let's talk about amplitude, period, phase shift, and vertical shift. Amplitude, remember, is the b value, so in this case it's the 6, so that's going to be a really high up graph. It's going to go up to 6 and down to negative 6. The period is 2 pi times a. A is a third. If you do 2 pi times a third, you get 2 pi over 3. The phase shift is the horizontal shift. It's moving to the right pi over 3, or you could say positive pi over 3. I like saying to the right because that way I know which direction to go if I were to graph this. And then lastly, the vertical shift is going down 2. Another type of question that students might come across is like the ones we've done. and like the one that we're about to do. This one gives you pieces of information and now you have to write the equation. So if you think about the amplitude is the b value. So that one is ready to go. The period does not give us the a value, it gives us clues on how to find the a value. If the period is pi, that means someone did 2 pi times a and the result was pi. So we have to think about what was a to make that 2 go away. Wouldn't the a have been a half? Because now the period is half as much as what it should have been. So if you're not sure what to make of the a value, always set up this equation. 2 pi a equals whatever the period is that they give you. 2 pi times a equals whatever they give you. Solve that now for a. So we would divide both sides by 2 pi, the pi's would cancel, we'd end up with 1/2. So this is telling me now that the a is a half. If I didn't know that, I would have been able to figure it out just by solving this. The phase shift, remember, is the horizontal shift, so it's pi over 2, and the vertical shift is -1. So there's no calculating I have to do for the rest. The period is the only one that's super tricky. So now let's go ahead and write our rules for each of these. The scale changes, remember, are your a and your b. So for the x, I want to say 1/2. So I don't need to worry about opposites here. I'll worry about opposites when I apply it to the equation. And the b value here is the 4, so that's just going to be 4y. The phase shift doesn't indicate a negative, so that must mean it's positive, or they would have said something about to the right or to the left. Since they don't, we can assume that it's a positive number. So we're just going to say x plus pi over 2. And then the vertical shift is negative, so indeed we would say y minus 1. Now we need to write the equation that's going to go with that. They told us to use sign, so we better use sign. You can write your equation as y equals, or you can do the y minus the b value over the d value. I'll accept it either way. I typically like to do it with the y alone. So if we go back to our notes from earlier, let's just peek back at what it's going to look like. In fact, let's just copy this. Let's just bring this back down to where we want it. So we're going to do a quick copy here and put this down here, and that'll help us remember what we're doing. And that didn't work. So let me try that again. Alright, now I've got it. So let's go ahead and just substitute in all the stuff that we've got. So our b value is a 4. The c value was pi over 2. It's already got the negative in there, so it's got to be opposite of that, so we're good to go there, pi over 2. A value was a half. Now be careful, we need to fix that. We can't say divide by a half, so we're going to modify that here in just a second. But for now we just substituted in the a value, and then I need the d value, which was the vertical shift, so that's going to be actually a -1. So whatever the sign is here, if you're putting it on the end, make sure that they match. Now dividing by a half is the same as what? Hopefully you said multiplying by 2. So our final answer for this one is going to be 4 sine 2, then in parentheses, x minus pi over 2 minus 1. You don't want to have the 2 on the inside of the parentheses because then that would have to be factored out later, and that would affect the pi over 2 as your phase shift. So make sure when you're dividing by a fraction that you do write it properly as the multiplication of the reciprocal, and it would need to go in front of the parentheses but after the sine or the cosine. So there's our final answer. Know that I would also accept it if you said y minus the b value, so that would have been the y plus the b value, which would have been the 1, and the d value, which would have been the 4. So I would have accepted it like this as well. One final way that I would also accept it is if you wanted to go ahead and distribute the 2, I would allow that. If you distribute the 2, you'd get a 2x there. 2 times negative pi over 2 would end up being just negative pi. So if you had that as your final answer, I would also accept that as being accurate. Alright, one final problem that we're going to do together. This one we're actually going to go ahead and give it a go on the graph. Fingers crossed on that. Here's another example where we need to factor out a number. So this coefficient on the x is not a 1 like it needs to be, so I'm going to pull this 3 to the outside. If I do that, I need to divide both pieces on the inside by 3. So let's write out what we've got so far. It's going to be y equals 2 cosine. The 3 comes on the outside. If I divide both of these by 3, that becomes just plain x, which is what I wanted. And let's just do a little scratch work over here that I'm going to erase later. Negative pi over 2, if I divide that by 3, remember that dividing by 3 is the same as multiplying by the reciprocal. The reciprocal of 3 is 1/3. So now I'm just going to say negative pi over 2 times 1/3, which is negative pi over 6. So I had to factor out a 3. When you do that, you divide both pieces by 3. Negative pi over 2 times 1/3, which means the same thing, is going to turn it into pi over 6. And then I still have the plus 1 on the outside. Let's write our rules next. The scale change rule is going to be whatever we're multiplying or dividing by. In the equation, we're multiplying by 3 for x. So in the rule, we're going to be dividing by 3 or multiplying by a 1/3. For the y value, we're currently multiplying by 2, so it's going to stay that way. For the translation, we've got x minus pi over 6, so we're going to say plus pi over 6 for the rule, and plus 1 for the y. Now there's these tables or charts here that I want to explain a little bit before we actually try them out. This is a method that I would recommend that you use if you are attempting to graph. Always start with since it's in radians, always start with all the key pieces or the compass points in radians. So this is pi over 2, which is the same as 90, or 12 o'clock. Pi, which is 180, 3 pi over 2, which is 270, and 2 pi, which is 360. So these are the same compass points that we're used to graphing. So we call this, or refer to this chart as the parent chart. This is the original graph, unmodified. And since we're doing cosine, let's fill in all those different points. Cosine starts at a 0 degree or 0 radian mark, but the the x value at the cosine is the value 1. So just think about all the cosines as you travel around the circle. Starting at 3 o'clock, which is where we are here, traveling up to 12 o'clock, it goes to 0, over to 180, 9 o'clock, it's -1, and so on. So these are our original coordinates that we're going to be using. Then, because this is the Rubberband Theorem, we will do which one of these two first? Stretch or translate? Think rubber band. Since it's a rubber band, we're going to do the scale change first, stretch it out, and then when you let go, you will translate. All you're going to do is follow the rules here with whatever column you're working with. So for my first set of x's, which are going to be from the scale change, I'm going to take all of the x's here and I'm going to multiply them by 1/3. So 0 times 1/3 is still going to be still going to be 0. Pi over 2 times 1/3 is going to be pi over 6. Pi times 1/3 is pi over 3. 3 pi over 2 times 1/3 is going to be 3 pi over 6, which reduces to pi over 2. 2 pi times 1/3 is going to be 2 pi over 3. So those are all the new x values that have been scale changed. Then to find the y values, we take the parent y values and follow the rules. So we're going to double all of them. So I'm going to do 2 times all of these values here. 2 times 1 is 2, 2 times 0 is 0, -1 times 2 is -2, and so on. And then I'm going to take the scale changed table and I'm going to perform the translation rule on that. So 0 plus pi over 6 for my first x value is going to be simply pi over 6. Then I've got pi over 6 and I'm going to add that to another pi over 6. So I get 2 pi over 6, which is pi over 3 when you reduce. Now here we're going to have to do a little bit of common denominator work. I've got pi over 3 as my next x. I'm adding it to pi over 6 here. So I have to change this to a 6 on the bottom by doubling it, so then I got to double the top. When I add there, 2 pi plus another pi is 3 pi over 6, so I get pi over 2. Now I'm at pi over 2, so let's see what we get for that. Pi over 2 plus pi over 6. Again, I got to worry about common denominator, so that's going to be 3 pi over 6. Add that to another pi, I get 4 pi over 6. When you reduce that, you get 2 pi over 3. This is just basic fraction stuff going on here, folks. And then on the last one, we've got 2 pi over 3, this one here, plus the pi over 6. Again, we got to worry about common denominator, so I'm going to double the top and the bottom. So I end up with 4 pi over 6, plus another pi is going to be 5 pi over 6. And so students, you don't need to worry about where those are going to be on the unit circle. We're just going to use those as our label. Now we need to go ahead and do the y values. So again, we're going from the scale change. We grab the y values and we're going to do whatever this says. So I'm going to take all of these numbers and add 1. 2 plus 1 is 3, 0 plus 1 is 1, negative 2 plus 1 is negative 1, 0 plus 1 is 1, 2 plus 1 is 3. Now I'm going to go ahead and attempt to graph this. So the table is telling me exactly what I need. I'm going to start with a nice big y-axis. I'm going to just label all the new x values that I have. So this is going to be pi over 6, next one is pi over 3, next one's pi over 2, next one's 2 pi over 3, and I got one more, 5 pi over 6. So students don't need to worry about if they know where those are, because those all came from the original, so we just labeled them as where they are now. I know I'm going to go up to 3, so I'm just going to label 1, 2, 3, and down to negative 1. So now we're just going to graph everything. Pi over 6 is up at 3, pi over 3 is down to 1, pi over 2 is down at negative 1, 2 pi over 3 is up back to 1, so I'm starting to see my wave starting to take shape now, and then 5 pi over 6 I'm back to a 3. Now I don't know where I'm crossing the y-axis because it's been shifted over, but that's okay. And don't force it either. If you don't know where it crosses, don't try to make it cross somewhere where you're not sure. And so definitely after it hits the highest point here, it's going to come back down, so I'm going to just make my graph look that way. But I'm confident that my numbers are accurate because I just followed the rule from the parent function.